Alex Bregman. He is 2 meters tall. Hit a 100 miles per hour. What's 100 miles per hour in meters per second? Let's say 25. Hit a ball 25 meters per second at a launch angle of 21 degrees. Okay. He's 2 meters high. The wall in outfield is 3 meters tall and is 400 feet, so let's say 120 meters away. Will Alex Bregman hit the ball out of the park? Okay, let's figure that out. Okay, so we have to figure out how long the ball is in the air. First of all, we need to figure out if it's gonna. We need to figure out how long it's in the air to see if it would actually travel far enough to even get to the wall. Okay, so we need our Vy. We need our accelerate or our velocity in the y direction. Okay, so our velocity in the y direction, as we've discussed before, is going to be our hypotenuse multiplied by the sine of our angle. So 25 sine 21. Or 8.96 meters per second. Okay, and our time from the bottom to the very top is our delta Vy equals acceleration multiplied by time. And our final velocity as it goes up and down is 0. So we're going to have Vf, which is 0, minus initial velocity, which is our 8.96, multiplied by our acceleration, which is gravity, multiplied by time, which is what we're figuring out. So this is going to be nothing, so we have negative 8.96 equals negative 9.8 multiplied by time. Divide both sides by negative 9.8. And we find out that our ball is in the air 0.9142 seconds. Okay, and that's just from when he hits it to the time up. But of course, we need to multiply by 2 to find out how long it takes to come back down. Although, because it actually starts 2 meters up off the ground, what I want to do is hold off on just how long that is. Okay. So we know that it travels upwards for 0.914 seconds. Okay, and actually, let's go ahead and give me a little more space. Okay, but that's how long it takes to go up. And let's find out how far it goes up. Our delta y, which again, because we can figure it out either way, from up looking down or from down looking up, we can use this equation. Delta y equals 1/2 9.8 multiplied by 0.914 squared. So take the square root of that, multiply it by 9.8, multiply it by 0.5. So we find out that the ball actually goes upwards 4.095 meters from where it was hit. Okay, but Alex Bregman is 2 meters tall, so it goes up 4.095 meters, which means that it goes up 4.095 meters in 9.14 seconds from when it was hit, but that it actually falls down this far plus the height of Alex Bregman. So it actually falls down 6.095 meters. So we can reuse our equation again to find out how long it's going to take for it to fall from its highest point. And we're going to solve for our time again. Again, our fall is the height that it was hit to plus how high it was hit from, or 6.095 equals 1/2 9.8 multiplied by time squared. Okay? And if we divide both sides by 1/2 times 9.8, it cancels out on the right side, and we're left with delta t squared. So that divided by 0.5 times 9.8 equals delta t squared of 1.244 seconds squared. Square root of both sides. Our delta t is 1.115 seconds. So our total time is this guy plus this guy, or a total time in the air of 2.03 seconds. Okay, it's not looking good, actually. I should have come up with different numbers. Anyway, but now what we need is this equation. Delta x equals our Vx multiplied by our time. We're just trying to figure out if it's going to go far enough to get out of the park. And I can already tell it's not going to be. But to calculate our Vx, just like we did with our Vy, it's going to be 25 cosine of 21 degrees. Which gives us 23.34 meters per second. That's our Vx, our velocity in that direction. And if we plug it back into this equation up here, we have our delta x is equal to our 23.34 multiplied by our 2.03 seconds, which gives us 47.36 meters. So more or less, Alex Bregman hits it just out of the infield, probably good enough for a hit, but not good enough for a home run. Okay. And just the way this thing is looking, me lecturing to myself, I'm very happy that some of you will get a chance to look at this later on.